This is a short tutorial on using de Moivre's theorem. So this example 1, we're going to write the complex number root 2 plus root 2i to the 4th power in standard a plus bi form. I've got a plus bi form sort of explained up here. A is the number that does not have the complex number associated with it, and b is the number that is multiplied by that complex number. So in this case, our a is root 2 and our b is also root 2. It's kind of a special case. It's not really indicative of the types of problems you'll see. Or it doesn't say anything about them, rather. So step 1 is to write the equation just in polar form. So we're going to take this original equation, root 2 plus root 2i, and we're going to rewrite it in polar form. Well, polar form just looks like this right here. We have z, which is our complex number, equals r times the cosine of theta plus I sine theta. Now, r is just given by a squared plus b squared. So the same a and b that show up in our equation, well, if I square this one, square that one, add them together and take the square root, that basically gives me this r right here. So to convert to polar form, I'm trying to fill in the r and I'm trying to fill in the theta here. Cosine and the sine always just go in the same places along with that I. So now theta is just given by the inverse tangent of b over a. Once again, that's the same b that's in our initial form and the same a that's in our initial form over here. So now I can just go ahead and calculate r and theta. So r is just a squared plus b squared. Go ahead and square the root 2. I get 2. Add those two together, I get 4. I take the square root of 4, obviously it's going to be 2. On the theta side, we're going to do the exact same thing. We have theta is equal to the tan inverse. So I have b over a, which is root 2 over 2. Remember, in this case, they were the same. So that's going to be theta is equal to the inverse tangent of 1. So when I take that inverse tangent, when I calculate that, crunch that number, I get pi over 4 as my theta. So now I have r, I have theta. I can go ahead and plug it right into my equation. And I get z is equal to 2 times cosine pi over 4 plus I sine pi over 4, right there. The next video will continue on with the same example.